problem solving session of Advanced Geomatics Engineering. Today we are going to discuss about the content from week 7. So we'll wait for a couple of more minutes so everyone can join, and then after we'll start our problem solving session. So now let's get started. Hello everyone, my name is Hiren Solanki. I am a fourth year PhD scholar at IIT Gandhinagar in the discipline of Earth Sciences. I am working on the application of machine learning and deep learning in stream flow prediction and flood forecasting. And I'm currently conducting this doubt session classes for Advanced Geomatics Engineering. So till now, we discussed about the different advanced geomatics engineering topics, such as we went through the maps, scales, photogrammetry, then GPS last week, remote sensing, 2 weeks we spent on remote sensing, data acquisition, processing, image interpretations, and some classes on photogrammetries as well. Now the previous class was divided into 5 lectures. Out of that, one was on GPS applications, which we already covered in our previous doubt session. Then the rest of the 3 classes were based on the LiDAR. So what is a LiDAR, how it can collect the data using different kind of scanners, mobile or static, and then what kind of applications you can do using the different sensors of LiDAR. And then the last lecture was based on the UAVs, or you can say it's drone. So in this doubt session class, we are going to focus more on LiDAR. And then after, in the next week, we are going to focus more on the UAVs and drones. So with that, let's start today's session. So first, we will solve some of the questions based on the previous week's videos, which are based on LiDAR. And then after, I will show you some of the applications of LiDAR, how you can use the LiDAR data in your analysis if you are working on, from where you can get the sample LiDAR data, how to process it, and how to visualize it in the softwares like QGIS. So with that, let's start. So our first question is, what is the full form of So our first question is, what is the full form of laser? So laser is like a technology which we use in LiDAR, and what is the full form of it? Is it light amplification by stimulated emission of radiation, light absorption by stimulated emission of radiation, light amplification by spontaneous emission of radiation, or light absorption by spontaneous emission of radiation? So the correct answer here is light amplification by stimulated emission of radiation. So as you might have learned in your physics that if electron is there, if you put some energy onto that electron, it will stimulate and go to the upper levels, and then it will while going from one state to another state, it will emit the radiations. So that's why that is a concept which we use in laser. This is not the absorption, it's the amplification, and amplification by stimulated emission, not the spontaneous emission. The next one is, which of the following is not true for laser? So narrow band, high divergence, defined wavelength, and stabilizes measurement for point observations. So the correct answer here is high divergence. Why? Because lasers are having very low divergence, and because of that it can penetrate to some specific distance and specific object with minimal intrusions. Further, it also has very narrow band, and the wavelength is also particularly defined for laser, and it's like we can get the very stabilized measurement using laser, whether it's a point observations or area observations. So the false one is high divergence because it has very less divergence. The next question is, what does LiDAR stands for? So this LiDAR, light detection and ranging, laser imaging detection and ranging, light interferometry and detection ranging, and fourth one is light illumination, detection and ranging. So the correct answer here is light detection and ranging. So how does this work is, basically we will put the laser, or we'll just put the laser, it will go reach to the object, such as, let's say if I am having this bottle, so what I will do is, let's say this is the bottle, and let's say here the laser is going, it is hitting this bottle and coming back to me, and I am recording how much time it took, and then I already know the velocity at which it is traveling, so I can multiply with the time taken into particular velocity with it, which like cover that distance, then I will get the distance between this to my point and that bottle. So between the any object. So it detection means it is going and coming back. So we are detecting it, and based on that we are ranging it, or ranging means measuring it. The next question is, what is the primary function of LiDAR system? So the primary function of LiDAR is, first, to detect sound waves for obstacle avoidance, to measure the speed of moving objects using radio waves, to create a 3D map by bouncing the laser pulse of objects, or to convert the high energy into electric signals. So generally we do use laser for detecting the object property, where it is, how far it is, and what is the location of it. So the correct answer here is the 3D geometry of the object. So laser is going, bouncing back from the object, and we are measuring the dimensions of that object. This is very useful when we go for self-driving cars or self-driving bikes, when we want to detect what is going to come in between, and then there are a couple of ML and DL algorithms which will detect what kind of things which is coming, whether it's another vehicle or another person or same type of vehicle, or if four-wheeler is there, then two-wheeler or very big vehicle is coming. Based on that, it can decide what to do, what not to do, and then it will take the decisions for automated uh, workflows. And the thing is, it does not use radio waves, but like we can measure the speed also, because if we know the distance at two different time frames, we can find out the speed as well. But the problem with option B is that it does not use radio waves, it uses the infrared lights. Now the next question is, LiDAR device uses laser beams, structured light mesh, pulse, white light. So it uses all of the above. The next question is, which of the following is an application of laser? The first one is barcode scanner. The second one is medical surgery. Third one is optical communication, and the next one is all of the above. Yeah. Are you able to hear me and able to see my screen?
Yes, sir.
Yeah, okay, great. Yeah, so hello both of you. What we started is we started solving the questions on LiDAR. Uh, so I think you just joined, so we'll go through it again. So we just solved 5 questions here till now. So we'll try to do this again for one more time quickly, so you can go through it. Yeah, so we started with what is the full form of laser. So it's light amplification by stimulated emissions of radiation. Then, which of the following is not true for laser? So it's a narrow band, high divergence, defined wavelength, and stability measurements for point observation. So generally, when we use laser, it is having very low divergence, and because of that, the option B is incorrect. The third question was, what does LiDAR stands for? So the full form of LiDAR is light detection and ranging. The next one is, what is the primary function of LiDAR system? So generally we do use LiDAR to get the location information or positional information or the shape property of object. So basically to create a 3D maps by bouncing the laser pulse of the object. And the fifth question was, LiDAR device uses laser beams, structured light mesh, or pulse white light, or all of the above. So the answer was all of the above. So now before going to solve next questions, I just wanted to ask you, do you guys have any questions from the lectures video of last week? So any questions from the last week or last doubt session or any of the previous week's content?
No, sir.
Okay, so if there is no question, then we will start solving these questions. In between, if you have any questions, please unmute yourself and ask. Yes. So the next question is, which of the following is an application of laser? So barcode scanner, medical surgery, optical communication, or all of the above? Any guess?
All of the those.
Yes, so we can use laser for all the applications. Barcode scanner you might have seen in your real life, but near to metro stations, in your school, in your libraries. Medical surgeries, we can use laser to cut some part or some kind of cutting or very precise measurements we need. Then optical stimulation to transmit the data or transmit the network. We need this laser as it has very less divergence and high power so that we can use it without loss compared to other signals. Then the next one is, what is the main advantage of laser? Precise measurements, minimal intrusion, fine detailing, and the use of infrared wavelength. So if you have heard in videos that laser is very like it's very stable, low divergence, and it can give you the very precise measurement. The accuracy is in mm and centimeters. So because of that, it can give us the precise measurements where we are interested in detailing of the objects. Apart from that, like when we are using laser, we are not disturbing the surface or the object. And because of that, there is very minimal intrusion. If the object is going to affected by laser, then and then it will create an issue. Otherwise, there is a very minimal intrusion in case of laser. The next one is like, as I told that it can do very precise measurements in less time. So we can get the very fine detailing, such as if you want to digitize the historical buildings. Let's say if you are in Ahmedabad and you want to like make a replica of the poles, or like old poles or old cities or ancient cities or ancient buildings, Havelis or something like that. So there is a very fine detailings are there if you go to any temple also. So if you use laser, you can get all those fine detailings through laser and make a 3D replicate replica of it. The next one was use of infrared wavelength. So that is true that laser uses the infrared wavelength, but it is not an advantage of it. It's just a property that it uses the infrared wavelength. That's why that option is not correct. The next question is, which of the following is not a utility of LiDAR? High degree of automation, safe operations, highly affected by atmospheric conditions, efficient data collection. So any guess?
Safe operations.
Okay, so here like not a utility. So laser, as I told, like very minimal intrusions and there is no need of lots of persons also. So safe operations we can carry it out, such as like consider a bridge and you want to measure the deflection in bridge or how much that bridge is deflecting. So without going to river, or like if the river is too long, such as Ganga, and if we want to do this kind of thing, then there is like person has to go there and collect the observations or using some other thing. But in case of laser, we can just use from some distance and do the all the surveys. So operations are safe, but the problem is when there is a fog, when there is a rain or snow, at that time we cannot able to use lidar, and because of that it's like highly affected by the atmospheric conditions, and that's why it is not a utility of lidar. Apart from that, we can get the efficient data collection because in less time, very accurate with high detailing, we can get the data. High degree of automation, as like just laser is a pointer, if we use the robotic laser, or if we use it in aerial mode or area mode, then it can just scan the entire surface and it will give you the detailing of this particular surface. So high degree of automation is also there, safe operations and then efficient data collection. But it is severely affected by the atmospheric conditions such as rainy days, fogs, or during snow. The next one is, which of the following is false? So there are two kind of scanner, point scanner and one is the area scanner or the scanning laser scanner. So which of the following is a false in accordance with the both? The first one is speed of point laser device is slow. The second one is scanning laser is useful for large scale data acquisition. Third one is speed of point and scanning laser are both are same. And the last one is both produce point cloud data with XYZ information. So any guess here?
No, sir. No idea, sir.
So here there is two kind of laser. In one way, it will just get the data of one point and then it will come back and will record that point. And in another way, we will use the data for entire area, such as a part of a building or some part of a particular column or something like that. So when we are in one way, we are scanning a point, and in one method, we are scanning a some kind of structure or some kind of portion of a building or some kind of portion of an object. So when we are doing the survey using point laser, obviously we are doing point by point. That's why the speed will be less. So the first option, speed of point laser device is slow. So that is true. The second thing is it is scanning, like it scans your barcode or it scans your, like you during the COVID, you have done like multiple scanners. In airport also you have seen the multiple scanners. So the scanning lasers can go through the very large area in less time. And because of that, scanning lasers are speedy. So and it can like it's speedy as well, and it can cover the large scale area. So option A and B both are true. The third one is speed of point and scanning laser is same. So that is wrong. Why? Because point device are slow, whereas scanning lasers are fast. The next one is, so that is a false statement. And then the next statement is that both produces the data in XYZ format. So that is true that when you use laser, it gives you the data in terms of XYZ data that we termed as a point cloud data. So point means it's a three-dimensional point information which represents the X, Y, and Z of a point. And then cloud data, it means it's like cloud of lots of points. That's why it's known as a point cloud. It's like too much data volume you will having. Okay, so the correct answer here is that speed is not the same. It's a different. That's why the option C is incorrect or false. The next question is, which of the following is not a type of LiDAR? So there are like few types of LiDAR depending on where you are fixing your LiDAR sensor. So out of the given four, which of the following is not a type of LiDAR? So if you might have gone through the classes, there are three types of scanners. The first one is a terrestrial laser scanner, which you will put on land. You will put your laser scanner on a tripod and you will scan the area. The second one is a mobile laser scanner, in which you will put your LiDAR system onto some kind of moving automobile. It might be a car or bike or any device which is in mobile or which is moving. And the third one is airborne laser scanner. So there you will fix your laser device on some kind of instruments or device which is in air, such as aircraft or aeroplane or drone. And then satellite laser scanner. So that is wrong because there is no such kind of scanner, which is like type of scanner which is present in satellite lasers. Although some satellite uses laser, but specific kind of naming conventions are not there. The next question is, which scanner is useful for mapping historical site? So as I told you, such as if you go to Mohenjo-daro or Dholavira or Lothal, so such kind of archaeological sites, and you want to map those sites that you want to create a 3D model to preserve the structure of it and to get some information out of it. So how you can map that? So the first option is dynamic laser scanning. The second one is long range static laser scanning. Third one is medium range static laser scanning, and the fourth one is short range static laser scanning. So which of the following is true?
Short range static laser scanning.
Okay, so short is like very less distance. Short generally we use when we want to do something with our body, such as we want to measure a body temperature or our entire body scanning for health applications or medical application. So the distance between the U and laser is very, or LiDAR is very less. So those applications will not come here, and like it will, so that's why it is not useful for historical site. And then like here the first thing is, first option is for dynamic and third option, three options are for static. So obviously if we are measuring the building, then we need to be in static condition. If we go dynamic, then it will not able to capture the fine details. So the first option is nullified. The remainings are three. So for that you should know like what is a short range, medium range, and long range. Short is very less, medium is kind of moderate, which we need for historical sites or building purpose. Long range is for like some bridges or some like long scale transmission line, or if you want to do something like that, you can use it. So I will show you the applications in the class, so you get a better idea. So these are the three kinds of LiDAR system, which we just talked in the previous question. So there's three: terrestrial laser, mobile laser, and airborne laser, which we talked. And these are the some kind of terrestrial laser sensors. So now if we go to this range, so here you can see there is a terrestrial laser can be used in the dynamic mode or static mode. So close range applications like reverse engineering. So do you know about reverse engineering? Anyone, do you know about what is reverse engineering?
No, sir.
Okay, so reverse engineering is like if you want to design a bottle or if you want to design some kind of prototype of any like something, let's say we want to develop something like this bottle. Okay, so what we can do, we'll just fix the dimensions, everything in AutoCAD, and then we will do the production after doing the prototyping in product. The reverse engineering is you just have this product. So first you will get all the dimension, all the curves, how much curviness is there, how much like length is there, width is there, diameter is there. So first you will take a product which is already there. You will get the dimension of that product, and then after you will study that product, how what is the advantage of it, or how it is being made, or if you want to made it, then how you can made. So that is a reverse engineering. So this close range applications, which is from 0.5 to 2 meter, which can be used for reverse engineering, body scanning, medicine, and police applications. Whereas medium range applications are useful in facility management, industry, civil engineering, geology, architecture, and cultural heritage, which has around 1 to 150 meter accuracy. Or long range is like when the distance is like more than 150 to 1000 meters, like 1 kilometer. So it's kind of monitoring of city or any kind of monitoring of transmission line or something, or mining applications where we do not need much, like it's when the object is not let's say far away from the laser. Okay, so now let's get back to, so the correct answer here is medium range static laser scanning. The next question is, which of the following is true for LiDAR? So LiDAR has 10 to 15 centimeter accuracy in height, 30 to 60 meter accuracy in horizontal direction, 300 square kilometer coverage per hour. So in 1 hour, it can collect the area of 300 square kilometer, and it operates anytime in all weather conditions. So
Sir,
as I, yes,
option A and B are
A and B, right.
yes, sir.
So you are true. So A and B is right. Apart from that, option C is also right, that it can cover 300 square kilometer uh, coverage per hour. That's why we can do a rapid survey. And the last option operates anytime in all weather condition. So yeah, we can use laser or LiDAR during day and night time because it's an active kind of remote sensing. We are having our own source of energy. So it doesn't matter we are doing survey during daytime or night time. But it cannot be useful for all weather condition, because if there is a fog or if there is a rain, then it will chance to divert the laser, and because of that it is not for all weather condition. It's just for when we do not have much fog or clouds, or if we are doing a rain is not there, then in those applications only we can use LiDAR. So that's why option D is not correct, and the rest of the three are correct. So the next question is, which of the following is an application of mobile laser scanner? So mobile laser scanner, so as we heard, like static is there, mobile is there, and then airborne is there. So static we just mostly referred as a terrestrial. Mobile, then we'll just fit that instrument on some kind of device which is automobile, and then we are having airborne. So when we talk about mobile laser scanner, what is the application of it? So consider this, we are moving and doing the survey, or we are in moving condition and we are collecting the data. So in which conditions we can use this? Any guess? So the first option is bridge deformation analysis. So here the question is how much bridge has deformed. Okay, so you have heard of different collapses of bridge are happening because of do not have proper quality check or proper maintenance check before the monsoon season, or submitted the wrong report, or because of those issues. So if you want to carry out the analysis of this breach, what is the condition of it, how much deformation has happened? If we go in moving way and collect the data, it might be problematic because it will not capture the deflections, because this might be in mm's or very less. So because of that, those applications require static or terrestrial laser, not the mobile. Similarly, whether the dam is bulged. So why dam is bulging or stress is developing behind the dam? Because let's say all of a sudden so much water came behind the dam and it is exerting pressure on the dam, and we want to see that whether because of due to that pressure is there any crack or is there any bulging. Like if it is, it will bulge. Like if this is the dam and if it is moving, like putting the pressures, then it will try to bulge and you see that bulging. So is that happening or not? So here also if we do the mobile application, then it is very difficult to capture that bulging. Similarly, the third or like fourth one, stop stability monitoring. So landslide and all this happening will happen or not, or how much is stability of slope. So for that also we have to do static survey, not the dynamic. Otherwise we will not able to see the property and how it is going to slip or rupture. But in case of monitoring power transmission line, so here just we want to monitor, is there any issue, is it touching the vegetations, or the very distance between the like transmission line and vegetation is very less. So we just want to monitor it, we don't want to do any kind of analysis, just monitoring that whether there's something issue is there or not, and if there we will go there at particular locations and we will do the appropriate actions. So the third option is just monitoring purpose, and that's why it is a correct application for mobile laser scanning. Any other applications where you can use this mobile laser scanner? So basically, if you have any construction site and if you want to see the progress of it, just progress or monitoring the progress, or if any project is there, highway construction is going on, and if you want to monitor the project, how much work has been done. So for those applications, you can use this kind of mobile laser scanners. Now we will move to the next question, which is what is an advantage of mobile laser systems or mobile laser scanners? So the first option is easy to monitor site progress. Second one is time saving with high frequency. Third one is high accuracy but coarse resolution. Fourth one is high accuracy with less time. So any guess? So as we discussed, it's easy to monitor site progress. So option A is correct. Now we do not have to go to site. We can just put it like some kind of vehicle and we can do the survey. So it will take reduce the time and we can do that so many times. So it will increase the frequency also. Then the third thing is high accuracy but coarse resolution. So overall, if you see LiDAR, the resolution is very high for this kind of applications, and because of that, the accuracy and resolution is also high in this case. But the cost will be very high in comparison. So high accuracy and less time, that is also true. But C is not true because we get high accuracy with fine details or good resolution. The next question is, which scanner would you use for watershed management? So first of all, any one of you know what is watershed?
No, sir.
So can you just brief me about your background, like from which civil or which kind of background do you have?
Yes, sir. I'm from Bachelor of Engineering in Geomatics
Okay,
from Tamil Nadu.
okay. So first I will tell you what is watershed. So it is useful when you do the any applications regarding the hydrology. So when we define the watershed, it is the, let's say, if we want to create a bridge or we want to, just a minute. So let's say if we want to create something at this location, which is, let's say we want to create a dam. And then once we want to create something, dam, bridge or any hydraulic structure, we should know from which area water is coming at this particular location. So we create an area which can contribute water to this location. That is known as a watershed. And based on that, we define the river systems. So if you see major river systems, we have 15 to 18 major river systems such as Ganga, Narmada, Tapi, Mahanadi, Krishna, Kaveri, Pennar. So like you just take a point where you want to study and you will create the area which will define that how much area is contributing to the water at given location. That is known as a watershed. And this analysis you can do once you have your digital data, digital elevation data sets. So this standardized workflow is there. If you have DM data, then you can do it. So now, as you know that this area might be very big because river do originate in mountain and meets into the ocean. So this area from where it is starting to its going to meeting the ocean, that is very large. And because of that, this terrestrial leisure and mobile leisure will not become like important to us because we want to cover a lot of area here. And because of that, the airborne laser systems or airborne LiDAR system will help in this case. So ALS is airborne LiDAR sensors or airborne LiDAR system. So if the area is too big, then we can use it ALS. So basically, if the area is very static in nature and we need high precision and detailing, then we can go for terrestrial laser scanners, multiple laser scanner where we want to do monitor progress or monitor sites, then it will be useful. ALS is like when you want to cover a larger area, such as if some smart city is coming up or some metro line is coming up with like connecting two different states or national highway construction, or you have a larger product that you want to do an analysis of entire city, such as Mumbai city or Surat city, something like that. So in that case, airborne LiDAR system will be helpful. Yeah. Hi, Adarsh. Welcome to the class.
Yes, sir. Good evening, sir.
Yeah. So we are discussing some questions on LiDAR. So our next question is, which of the following is not a scanning method in ALS? So ALS is airborne LiDAR system. So which do the scanning. So basically how we are scanning the area. If we have laser system mounted on some kind of airplane or aircraft, how does it makes, like in the previous class when we did the photogrammetry, there you learned that there is two type of system, push broom and whisk broom system for scanning. So in case of LiDAR, which is the method which we do use? Is it zigzag scanning, push broom scanning, parallel scanning and elliptical scan? Which of the following is not a scanning method?
Parallel scanning is not a scanning method.
Yes, so the correct answer here is push broom scanning. So if you go through the, just a minute. So if you go through the video lectures, mm, so here it has three types of scanning. So this is like how the scanning will done through this scanner. And here you can see it's a zigzag scanning. So it's going on left side, right side, left side, right side, like this. So there are these three kind of systems which are there. So there is a zigzag scanning, parallel scanning. So it will do for one line, then another line, third line. And there is a third one, which is elliptical scanning. And when you have this LiDAR system, then you have the scanner, which will obviously scan the things, then ranging unit, which will send the pulses or lasers to the ground and it will come back, then one control unit or monitoring unit or recording unit, so which will keep in mind of all the component. Then there will be a GPS which will record the locations, and then IMU to stabilize your system. So the correct answer here is a push broom scanning. So it is not a scanning method in ALS in terms of when you use this standard terminologies. The next one is, so are you able to see my screen with the questions?
Yes, sir.
Okay. So the next one is, which of the following is not a part of LiDAR system? Control unit, IMU, DGPS, and processing unit.
Processing unit.
Yes. The next question is, which of the following is true? First pulse detect the top of the object. So when the laser, this is in context of when this airborne LiDAR systems are sending a signals, then first pulse detect the top of the object, first pulse detect the ground condition, last pulse is used for ground conditions, and intermediate pulses show the vertical structure.
A and D are true.
A and
D.
yes, A is true, D is true. What about B and C? Are they false? Or so if first pulse is detecting top of the objects, then obviously B is not correct. But what about the last pulse? Will it give you the idea about ground condition?
Not sure, sir.
Okay, so here it will give, so it will give you the last pulse will give you the idea about the ground condition, and first about the first object. So if you go through this, like this figure, if you can see here, so first pulse will come here and it will go back. So first will give you the about the top surface, and then intermediate pulse will give the height information, and the last pulse will give you the ground details. So it will work in this way. So the option A, C, and D, three are correct. The next question is, which of the following is a limitation of LiDAR? Coarse resolution in height data, works only in daytime, cannot measure the distance in heavy rain or snow, and none of the above.
Sir, is it C?
Yes, C is right. It cannot measure the distance in heavy rain and snow. And it is giving fine detailing, so option A is not correct. Works only in daytime. No. Laser we can use. It's a, like we have active sensor, so we do not need any other energy source. So we can use it at daytime or nighttime. So that is not the limitation. So option C, like if there is heavy rain, snow, or fog, then we cannot use LiDAR because it has capacity to deflect the signal. Which factor can reduce the accuracy of LiDAR? Time of the survey when you are doing the LiDAR survey, GPS error, angular errors, time synchronization issue.
Time synchronization.
Yes, so this is a multiple choice. Any other option is right? Do you think so? So we do have GPS, and in last class we learned about the GPS. GPS has its own limitations, own errors, such as errors which is generating because of atmospheric part, errors which is because of the satellite part and receiver side part. So we do also have GPS errors as well as angular errors, like where how it is and which angle it is confirming the putting the lasers and all. So time
But
of survey, yes,
sir, but LiDAR is a independent system, no?
yes, but like see, lidar can just what is the principle that lidar will go and come back, like it will go bounce with the object and come back, and we will able to record how much time it has taken. Okay, now that is not useful for us because when we want to do survey, we need the location information also. So let's say we also have to assign X, Y, and Z. And that's why with LiDAR sensors, we put the GPS so that we can give the georeference the image. Or it is also known as we can give the locational information to our image or our points which we are collecting. Otherwise, it will collect the data. Okay, but you will not get to know that from which location it has collected the data. So although LiDAR is separate system, we do put DGPS or any other GPS systems, mostly DGPS, so that it can give the positional information as well.
Okay, sir.
Okay. In general, it will just give the XYZ, but how you will define XYZ, you need a GPS for that. The next thing is what is the key challenge in using LiDAR and foggy or wind conditions for self-driving cars. So lasers are too powerful. System relies on radio waves, not lights. Fog
See,
or yes. So fog and particles will interfere with the laser pulses.
sir, one more thing.
Yes.
Uh, Sir, if the laser is of a different kind, like X-ray or something, will it interfere?
Yes, see, if it is too much, then in that case it will try to interfere. So then it will go to the like generally it uses the infrared light. Okay, so in general case, so as you learned in the scattering part that it might interfere sometime, but if it is very less, then it might penetrate through also. So all depend on which wavelength you are using, but most of the cases it will interfere.
Okay, sir.
The last question for this LiDAR is which of the following are advantages of LiDAR for data collection?
High resolution, ground detection in forest, and centimeter level accuracy.
So all of the are above. So everything is true. So if you want to know more about the error part, so I think you can go and check the last part of this class, where is in the lecture number 34. If you go at the end, there is a different kinds of error which can come in LiDAR is been given. So mostly it's a GPS and like integrated part. So there is majorly two error, majorly angular measurement error, which is coming from the altitude angle, and scan angle error is coming from GPS and INS integrated. So mostly is angle measurement error, which can be divided into attitude angle and scan angle error. Attitude angle and scan angle. And then other is time synchronization, measuring the angle of error, ranging error, interpolation error. So that is the other thing. Now, this is the like this week is not much on question part. So we have just completed the question answer bit early. Now, before going forward, do you have any other questions from previous class? Those who joined late?
Sir, I have a different question.
Yes.
Sir, actually, in NPTEL, when I'm logging in for the document verification, it's just a semicircle kind of thing,
Okay.
not a tick. So, will I get that confirmation, or is it in
I
still
you
process?
in this case, what you can do is this issue. I mean I don't have like I cannot resolve. So what you can do is you can go to this NPTEL page of this course and go to question and answer Q&A. Okay, so in Q&A session, you put your query there, and the person from this management side will take this query and resolve this. So you can just put your question or issue here.
New conversation.
Just here, write down whatever the issue you are having and just share in this forum.
Okay, sir.
Okay, so they will help you in this regard. Anything else from the previous classes or so now I think we have sufficient time of 1 hour. So one thing what we can do is I can show you how LiDAR data looks like and how we can visualize it in QGIS or something like that. Or second thing which we can do is if you want to discuss, if you are doing any work on remote sensing, GPS, LiDAR or something, then you can discuss that work with me if you need any suggestions or something like that. So that we can do. So how do we start now?
Some mapping.
Okay, so and so you want to go with the visualization of this LiDAR part. Any other suggestions, guys? Okay, so if there is no more suggestions, I think I will show you the how LiDAR data will look like. So first of all, we will just has anyone worked with the LiDAR data before?
No, sir.
Okay. DM data, so digital elevation models. So have you worked with that?
No, sir. I'm just from BTech.
Okay, so BTech in which discipline?
CSE.
CSE. Okay. So have you used any satellite data before?
No, sir. Just programming.
Okay. Any image data?
Image data means I have
Any
used some.
have you worked with any image before?
Image means
So just taking your image and doing some operations on that, or any image of dog and cat classification or something like
yeah,
that.
I have used classification and all in ML.
Okay, okay. So when we talk image, what does it have? How we represent it mathematically?
Actually, it is stored in array
Huh,
RGB.
we can term it as a matrix, just a matrix. Okay. And when we take a image, it's a matrix like RGB, three bands are there. So you will having three bands, and sometimes there is another band which is for opacity. So in some case, most of the cases, you will get three band, but in some cases you will get one more opacity band also. So all the remote sensing data of satellites will be in this format only. But there is a catch that normal image which you take from camera, it having three band, but remote sensing images will be having lots of number of bands. So apart from RGB, you have multiple bands. Now the next thing is how do we collect image? So you have camera, okay, and you have any other sensor. So once you just take a normal phone and if you take image of any particular thing, if you take photo, what is happening in real life? So what you are sensing?
They are just capturing light in different
Exactly. So the
angles.
reflectance which is coming to us, okay, and that we are reflecting, like representing in terms of matrix. So how much sensitivity is there? Like how much intensity of light it has recorded in R band, G band, and blue band or RGB band. So basically, depending on how much information that pixel can solve, like store, depending on that, how much storage is there, we can have the different gray levels that we have learned in the spectral resolution during the remote sensing class. So now think about the same way we have the elevation data, which we termed as a digital elevation models. You have also heard about these terminologies in the starting of the class when we are talking about the photogrammetry, when we want to generate a 3D view from 2D images. Okay, so this DM data or DSM data or DTM data, whatever you can see or heard of, these are just metrics where the value which is there inside the matrix, it will represent the elevation of the that particular location. So generally for that, I mean to visualize this geospatial data, we use a software known as QGIS, which is a quantum geographic information system. And in the this particular class also in the last two lecture of last 2 weeks, you will heard about this geographical information system. So till now, whatever the data which we have used, that data you can visualize using this software. This is a freely available software and open source. If you want to install this, you can use QGIS download and you can download this software from their website. So you can just go here on download page and you can download it for any system, whether that's Windows, MacBook or Linux. So it is supportable, like it supports all the three operating system. And yeah, right now it's not opening, but yeah, it's so you can download it from this site. So it's just opened. So here once you open, then if it is Windows, you can just install the long-term version for Windows. And once you download, then install, it's just you have to next, and this it is have to install. If you are using it and if you are having an installation error, you can keep back to, like get back to me in that case. But it's very easy procedure. So once you download this software and you have to load this, open this in your system. So once like it's opening, what I will show you from where you can download this data from related to this LiDAR sensors or elevation data or any kind of height related information. So this site we have discussed in the previous lectures also. So the name of the site is Open Topography. So this is the collaborative site where we share the data related to the elevation. Apart from that, this scanner data, laser scanner data, drone data, that also we share here. So here you can just go to data and data catalog. So now in data catalog, you can see there is a three tabs: global and regional, high resolution topography, and community contributed project. Now if you go to high resolution topography, because this LiDAR data is very high resolution. So you can see here this data, Auckland Part 2 New Zealand 2024 datasets. Now this data is here, it's written get point cloud data and get raster data. In some of the data set, it is also written get raster data, or here it is written get point cloud data. So once you click on that get point cloud data, so this is the data collected by LiDAR. So once you click on that data set, first it will give you the information or overview about the data set. So LiDAR was captured. So LiDAR data was captured for Oakland Council by Woolpert between 26th of June and 4th of November 2024. And the dataset was generated by Woolpert and their subcontractors. So these are the persons who are involved within this work. Now, which platform they used? So they used airborne LiDAR. They surveyed around 3,507 kilometers square of area. Now the next thing is point density. So how many points they are taking. So when we are referring to point cloud, how many points they are actually taking per meter square. So they are taking around 19 points per meter square. Now you can think of meter square is very less area. Like if you have tiles and or something, if you just have a measuring tape in your home, you can just measure how much area is there like in 1 meter by 1 meter. So we are taking 19 observation at least in 1 meter square. So you can think of its very high resolution survey, and we can go to centimeter level or sub-centimeter level also using this. Now, if you want to know more about this, then you can click on metadata. So if you go and then you can check their metadata entirely. So there will be a detailed about the scanning, then what are the different classes that they have given. So here they have classified their data as a unclassified, ground, low vegetation, medium vegetation, high vegetation, building, low point, water, breach deck, high noise, and reserve. And then this is the coordinate system. So basically when you download any data, and if it is having a, if you want to specify the location, it will be coordinate system will be associated with it. And this coordinate system, the unique identifier which we will refer as a EPSG 2193. So there will be EPSG, which is a unique identification, and then there will be a particular number which will represent the given coordinate system. So coordinate system, like if you want to specify something on map, we will take reference as a 0,0. Now here different countries have defined their own X and Y, own origin. So that you have to refer to avoid the errors in area. So this is for X and Y information, and this is for Z information in vertical dimensions. Units of the data in meter. These are the survey report and the how they have done the validation. So I mean, you can go to this thing and you can check out the entire how much survey they have done, how much data they have created, how they have created. So entire details you can get from here if you want to know in detail which LiDAR instrument they used, which companies, how they done the post processing, how they divided into different classes, what is their accuracy. So all those things you will get in these reports. Now coming back to the data. So this is the data which they have collected. Okay, now what we will do, we will take, if you want to download these data sets, so what you have to do is, we want to download the point cloud data. So just go back and I will just go to some specific part where I want to download the data, because like our systems cannot handle the entire data all at the once, because we need a very good systems for working with this. So let's say I have selected this much area. Okay, now you can see here still warning is coming. The selector area contains approximately this many points, and you have the limit to this much points only. So what we'll do, we'll just try to reduce our area because the point density is very high. So let's reduce the point area again. So still it is having around 24,87,000 points. So now let's go ahead with this. Now in this, which format you want to download your point cloud data, and then there is the option of calculate TAIN. So TAIN is a triangulated irregular network. So that I will just come after once we download the data. And this is like how, if you want to do the 3D visualization, you can click over here. And if you want other type of visualization in terms of raster, then you can click on this any of the parameter. So we will go, and now if you want to add any other parameters, you can do. And I will just give my email ID and submit this request. So now it started extracting this data, and we have given the two kinds of visualization. One is 3D point cloud visualization, and one is related to team data and hillshade. So it will take some time as the data volume is too much. So querying is done. So the last visualization is done. Now everything is done. And first, this is like data, how it is looking in team data hillshade. And if you want to see in 3D point cloud, then you just click over here. And you can see how your LiDAR data is looking like. So you can see a surface, and you can see how much point it has collected. Okay. So this very high resolution data and how this will look like. So all these things which you are seeing, it might be a tree because you can see the canopies are visible. So if you zoom it,
Sir, your voice is cracking.
okay. Now, so what I'm telling is, this is the data, how it look like in point cloud data, how you can visualize it in three-dimensional space. Okay. Now we just download this data again. So I mean, we have already given the request, so it has given the file, and I will just download the results. So it's 15 MB's data. Okay. So once you download the data, I will just drag and drop into my QGIS window. So I'll give you the brief overview about this software. So here we can use any spatial data, we can visualize that, we can do some operations on that, and these are the like how this will look like. Whatever data you will import, that will come in the center part. On right hand side, you have lots of tools for different kinds of operations. On right hand side, you are having browser panel through which you can open any sites or any data or any files or folder. Here in layers, whatever the layer you will import, that layers you can see. Here in the like on top, you are having menu bar, then different tools are there, and this is the data how it look like. Now if you want to visualize, like this is just points. If you see here, these are the multiple points which are being collected. So everywhere, and like which part from these points come from, which part of the world. So you can add just a base map. We can just put the Google satellite map here. So this is coming from these locations in Auckland, and you can see like this area is kind of woody area and lots of trees are available there and vegetation is there. So because of that, you can see that this is so much noise is there. Now, if you want to see that in detail, how does it look like? So what I will do is I will go to view and there is an option of elevation profile. I will click on that and then after I will create a line across some area, and now you can see a different thing. So here you can see different points are being visible. So I will just zoom it and then do, so you will see properly. So can you see here different points which are being laid?
Yes, sir.
Okay, so these are the points of LiDAR and I'll just increase the size of it. We'll make it round. Okay, so can you see it now properly?
Yes, sir.
Okay, so now how the color of this different dots will represent the different thing. So here you can see the brown color points they have classified as a ground. So those are the ground, like here ground is there. Then there is a low vegetation point. So low vegetation is means if grass or something is there. So you can see this light blue color. So that is represented by the grass or something like that. Very low vegetation. Then there is a medium vegetation. So little bit higher than grass. So you can see those points, light green points in this range. And then you have high dense vegetation. So basically the trees. So you can see the trees over here. So these are the canopies of tree. And then there is a low points. So which are the noise. So it is falling very below. And then high noise means it is just coming from the like very like away from the surface or away from the atmosphere if some bird is saying and some noise is there. So that is high noise and some low noise is there. But overall this will look like this. Now we can just use some longer stretch and we can visualize. So how this data is looking like. So you are having some low noise, because of that it is going below, but overall this data is around 100 meter. So you can zoom in and check basically. So this portion I want to check it. So now you can see here that here, like if I'm taking from this stretch to this stretch, here it's kind of hilly area and you can see there's lots of vegetations are there, and then there is a bottom. So it might be something kind of river or nala because elevation is dropping here, or valley, but there also it's having plants. Here you can see on top it will might get more sunlight or something, so vegetation growth is more and the tree height is more here in this region, and you can see this entire particular region. Now if we take a stretch like this, you can see it's dropping. So here basically this area has some high slope or elevated area, as you can see here. Okay, so like this is our LiDAR data will look like, but ultimately this is a point data and we want to create some visualization which is in 3D. Okay, so how we can do that? So now I will show you the one more thing which I, so you can see now here you can see the different trees are there, so you can visualize like this is a 3D model also given here, so you can check here that how this different trees will look like. Similarly, before the class, I have generated a data of some other region also, where trees are not there, but the topographic variations are there. So can you see here, this is some kind of lake is there here. Can you see it?
Yes, sir. So
So,
what are those red dots?
so this red dots are the LiDAR data which we collected. So through LiDAR, you will end up collecting these red points. So you will not get this surface. You will get these points which you are seeing in the space. So what I'm asking is, if you have this data, how will you generate the 3D surface? Similarly, if I show you the other visualization, here also you can see. Just make this visualization better again. So here you can see, here also you can see the points. Can you see?
Yes, sir.
So these are the points are like the data which you collect using LiDAR, and you can see how the site is changing. So here in between some kind of valley is there, and then these are the different trees are there, if you can see it properly. So wherever tree is there, the data will be high, and ground or grass is there, then the data will be less. So here they have done the generated the surface and they kept in the middle. That's why you are not able to focus it properly. So now what I will do is, let's say the question which I asking is, if you have these points, how will you generate continuous data out of it, which you were able to see here. See here you can see the surface which is continuous in nature at the bottom. Are you able to see this continuous surface?
Yes, sir.
Okay, so the question is, if you have this LiDAR data, how to generate this surface? So how you can do it, like in general?
We will try to draw polygons with adjacent points.
Okay, but see what was the pixel density we had? It was around 19 pixels per meter square. Okay, and how
Yes.
many points were there? Like around 50,000 or 50 lakh points were there. So how do we start marking a polygon?
With the adjacent points, we can start.
See, you are having points like this. Can you see?
Yes, sir.
So the question is, if you have in this multiple points, how will I see? If I will take these 2 points, it will be very difficult for me, because variation here, if you see the distance between these 2 points, it's just less than point, like it's 1 meter. It's just zero point 0.1 meter or 0.177 meter only. Sometimes if you take these points here which are there, its distance is like very less. See, it's just 0.028 meter. So distance is very less here. So if we start making polygons, it will be very difficult for us. Okay. So any idea what we can do here? Any guess you might want to take? Like this is a problem that we have given the point data to you, or we collected data using LiDAR. And now what we want to do, we want to create a continuous surface, which you see in, like we just want to create an image basically. So how we can do that? So basic idea is, you create a grid and take a interpolation. Basically do the interpolation. Rather than creating a polygon, do the interpolation. And how will you do the interpolation is, you first define the grid at which grid size you want to generate the data. Okay, so how this grid will look like? So I will generate a rectangular grid. And then you have to specify which grid resolution you want to keep, whether it's 0.1 meter or 0.5 meter or zero point 0.2 meter. So each pixel size you have to define here, the resolution of pixel. So currently I'm specifying a resolution of zero point 0.2 by point, let's say 0.5 by 0.5 meter. Okay, and then I will just generate my grid. So can you see this grid?
Yes, sir.
Okay. So now what I have to do is, this is the raster which I'm going to create. Raster, it means image which I'm going to create. Now, first I have to define the size of the grid, at which resolution I will give data to my user. So now this grid I have generated at 0.5 meter. So the size of the pixel will be 0.5 meter by 0.5 meter. Now if I want to specify the elevation in this particular area, what I will do, I will take a mean of all the points. Did you get my point? I will take mean elevation value of all the points which are coming in this grid. Okay.
Yes, sir.
Similarly, I will do for all the grids, and I will generate a continuous data. So basically, if you have a variation within the grid only, you might not be able to represent the surface well. But this is how the data is being created. You have to specify some dimension to it. And then you have to do interpolation. So now what I can do, I can run the interpolation algorithms at this resolution. So there is a very basic algorithm which is inverse distance weight. Have you heard about it? So anyone of you have heard about the, like, have you done the interpolation before first?
No, sir.
Okay. So interpolation is means, see, let's say today's temperature is 24 and let's say 2 days back temperature was around 21 degrees Celsius. Okay, now I'm asking what was the temperature yesterday. So now I know, like, on 4th of September temperature was 21 degree. Then on 5th, I don't know, question mark. And on 6th, the temperature is 24 degrees Celsius. So if you want to say in general, what might be the temperature, or let's say we'll make this value as a 22. So what you can tell that it might be around 23. Okay. So I will ask you that what is the temperature on 5th. So you might take, it might be 23, considering the temperature on 4th, temperature on 6th, and taking the average of it. So this is a simple linear interpolation. Did you get my point?
Yes, sir.
Now, when we are talking about topography, in that case, what will happen? So, in topography, our surface might be like this also. Okay, so this might be our surface. Now here, let's say I know elevation at this place first. So just paste it somewhere else.
Sir, are we doing this interpolation to reduce the file size?
Yes, file size also, and the another thing is you are having
Computation overhead.
data in point format. Okay, but if you want to visualize it, you have to make it as an image format. Okay, so basically to convert this point data into image data, that's why we are doing this interpolation. Okay, so this is the surface. Okay, now through LiDAR, we have collected different data sets at different locations. Let's say, just to make it to screen show. Okay, so let's say using LiDAR, you get a data here, you get a data here, you got one data here, you got one data here, and one data here. Okay. Now what I'm asking you, first I'm asking you, give me the data at this location. So the first thing is give me the data at this location. Okay, so what I will do, I know what is the data at this point, and I know what is the data from this point. So let's say this, if it is 10, if this is 11, or if it is, let's say, 10.5, then over here I will fit a line. So I will draw a line just passing through this 2 point, and what is whatever the elevation is there at this location, that I will take as answer. Okay, but now if the depends on all this surface, here I am considering the linear criteria, that the surface between these 2 points is linear. But if that surface is not linear, then in that case what will happen is, let's say in this case you will generate a linear surface, and if you interpolate, it will give you the answer at here. So basically the answer of elevation data might be here, but actually surface is not linear, so you have to get this one, but you are getting this much, so this much error is there in the generation. Okay, so depends, at that time you will not put the linear interpolation, you will put some kind of interpolation which will represent the surface as polynomial. So 2-degree polynomial, 3-degree polynomial, so in like that way. So this IDW interpolation, so inverse distance weight, how this interpolation will work is, it will consider the nearby points. Suppose if I want to find the elevation at this location, it will find all the nearby points. Let's say one point is here, one point is here, one here, one here. Then it will find the distance from all the points. So this is the D1, this is the D2, this is the D3, and this is the D4. Now it will give the weightage according to the distance. If the point is nearby, it will give more weightage to those points. If point is far away, then it will give less weightage to those points, and it will do the mean. But during mean, it will give weightage using the how far that point is. So that is the inverse distance weight interpolation. And how that work is, like in this QGIS, first you have to specify your point or vector data which has the grid. So you have to specify your data point first. First of all, this format is not usable. So first you have to export this into uh, like format which supports this IDW interpolation, and you have to do this IDW interpolation afterward. I have done it earlier. So basically, this data type of this LiDAR data is not supported in this QGIS. So this is the data type of this LiDAR data is in LAZ format. So here, if you want to do interpolation, it should be in .shp format or .csv format. So first of all, we have to convert our data from that to that. But generally, we do not use for processing LiDAR data this kind of software. You need a very good software. So this is just for visualization purpose I have done. So I will just show you how that results will look like. I have downloaded I already done this thing in the other softwares. I will show you that. So
Sir, means we have to convert this laser data to matrix.
yes, yes. So here I have some other laser LiDAR data. So once you do that interpolation, it will look something like this as an image. Okay, so here is the data given to you. It's like point only. So can you see these points? So like you can see the pattern, how the data has been collected, zigzag pattern or parallel pattern in that way. Now once you have all the data, you can do the interpolation and you will generate this file. So which is a raster file. Now can you see this? It is a continuous data, and like right now it is showing black because its values are ranging from 1953 to 2436. So if you just want to make it proper, you can assign some different colors so you can visualize it properly. So right now, so now can you able to see this thing, normal features. So after converting into this image format, which you have already looked here. So can you see this thing? So here one like depression is there, and then this is also depressed area, and here some hills kind of thing is there. So you can see the same thing here. I will just change the color differently so you can visualize it more.
So the sir color represents elevation.
Yes. So you can see here this dark blue color is a deeper area, and then here also it's a deeper area, and then here the elevation is quite high. So you can see the light blue color. And if you want to see this thing in 3D also, we can just check it out. So here, if you can put this thing into 3D also, put my DM layer. So you need mouse to better visualize these things. So can you see this thing?
Yes, sir.
Okay, so it's the same data, but once earlier it was a point data that we have converted into image format. And now you can see the different things properly. So here it might be lake or some kind of crater thing is there. Because of that also it might have formed like this. Okay, so this is like, that's what like our normal data is like just point data. So we have to convert from point to this kind of continuous data. So the first one was the discrete data, and that we have to convert into a continuous data frame. And now if you want to see like how much actual topography is there, how much this interpolated layer will look, and how much like DSM, DTM, those terminologies you have learned in the previous classes. So we will explore that as well. So here there is option of elevation profile, and what I will do is I will just create a, first I will just add all these my layers here. And I will rename it with the layers. So this is thin layer is the interpolated layer. Then this one is BE, which barren earth. So we can term it as a DEM. And this is HH is a DSM, which is a digital surface model. So if height of tree will also be included here. So these are the three products which we can generate after the DM, which we collect from LiDAR point cloud data. So now I will just draw a line from this location to this location. So can you see here? So this is the profile which I got. Now if you see your points, so there there's like white points are unclassified points. We can just see here the surface. So point density is too much, that's why we are not able to see. We'll just reduce it less. Still it's too much. We'll zoom it to some section. We can just reduce this. So we'll take a transit from here, so it is down. Okay, so now, so can you see it here now, like how the surface look likes, and this how the interpolated data, obviously it's at low resolution, so it will not show the actual topography. So you can see these steps are there in between. In interpolated data, these yellow lines are there, so you can see it's not capturing the variation properly. But this red and DM and DSM. So here right now there is just barren land, no vegetation, no building. So this DEM and DSM data both are mixing with each other. See, there is no difference between these two data sets. Both are similar because there is no something kind of thing, but you can see. But once we add this interpolation, so this interpolation you can see it might be less or high depending on the points. So you can see the points. This is the points which we have collected. I will just remove the unclassified points from here, and low points also I will remove. So make it round. Still there are so many number of points which are there because already data is too much. So that's what, like, to convert from this too much data to a surface, you need to do interpolation, then and then you are able to do this. So one more thing. So can you see the points now properly? We'll increase the size of point. Yeah, so now I think it's visible properly. So this is the original point collected using LiDAR. and then this like yellow color line is showing the interpolation using one of the method, which is triangular irregular network. And this orange line or red line which you are seeing, that is the line which is, you can see it's representing the point only. So converting our point data into some linear feature or some kind of continuous data like this. So that's what I was talking about. So your point data will look like this, which is, you can see as a point. And then there is a conversion of that into continuous data as a pixel. And once you plot these pixels, it will give you the idea about the surface. You can find out the slope. You can do how water will flow. You can do the lots of analysis after this. Is there any issue? So now are you acquainted with this LiDAR data? So is there any questions? Hello. Are you able to hear me?
Yes, sir.
Okay, so this is like how you can visualize the LiDAR data, but like most of the Indian data sets are not available for LiDAR. In some of the, like, because it's not available in public domain. But if you see in the lectures, then there are a couple of data sets which they have generated are given. So once you have this data, which will look something like this only, which we already looked how it's looked. So you can calculate the volume, calculate the area. You can specify this buildings, tree, depending on the site area from where. So this is like point which I referring, and this is like how the data, like which also looks like this also, in which what we considered. And you can generate this kind of application. You can do the slope, assets, 3D monitoring, volumetric estimation, grid inspection, and a couple of examples for LiDAR are given in this, I think lecture number 33 it's given. So if you see this class, so there they have used the mobile LiDAR systems, and then there are various couple of campus are given, such as this, you can see MNNIT Allahabad campus with this LiDAR data. So once you collect all the LiDAR data on top of it, like if RGB sensors are also placed along with this LiDAR sensor, and you can get the color of that pixel also, that which color that pixel is looking, and you can generate the separate R band, G band, and B band, and then you can visualize it as an image. So this you can do. And if you do not have the image, so yeah, this is the few campus, and this is the like Ames Patna site with 100-acre LiDAR data, and this is the textured map. And yeah, so what I was telling, that if you do not have 2D sensor, sorry, RGB sensors, so in that case, what you can do is, once you have this kind of file, then after you can represent, let's say, any base map you can put here. If you have some kind of imagery captured using some satellites, let's say ISRI satellites is there, ISRI data is there, Google satellite is there. So you can collect the data from there, and you can put that on top of your DEM model. So we will do that. So this is the DEM which we have, and go to 3D view. This we just used, and now I'll just generate another one. This is the DM, and then after on top of that you can put the other layers also. So you can use different properties from here, and you can generate the other layer also, X3 layer also. But you just have to, on top of each other, you have to put down those things. So once your base layer, which is the DM layer of your data, and on top of that you put the satellite imagery. Currently it's taking time in loading. Okay, so we'll not go into that part right now. So that's what you can do. There is another more plugin in QGIS, QGIS 23GIS. So there also you can use the same thing. You can have your DM data. So you can directly visualize the topography here. Let me just reduce the size view. Fine. So you can get something like this. So once you overlap the imagery, you can see what is there. Like if actual real imagery, if you have that also, you can collect it from drone and then you can put it and check it. Which feature do you have exactly on top of it? So this kind of thing you can do once you get the 3D models. So is there any questions now?
Sir,
Yes.
sir, if I try to reduce the time for the LiDAR scanning,
Hmm.
will it help or is it not needed?
Like what you want to reduce?
The time taking for that LiDAR data capturing, like if there is a site, so I am talking of that capturing data part.
So that you have to define like how much detailing you need in your work. So
No, no,
if
no,
you are
sir.
doing,
I am
huh?
asking for that. I want to reduce the time. For example, my
Time
work.
while taking the LiDAR points.
No, no. Actually,
Like
I am
during
saying
the
that.
survey or during this processing, like which
No, no,
I'm
no, no.
doing
I am
right
asking
now.
about my work. Actually, my work is to use swarm systems for that
Okay.
data capturing and all.
Hmm.
So if I use a swarm automated swarm system,
Hmm.
so we can use parallel drones for data capturing
Yes.
simultaneously.
Yes.
So
True.
it will reduce the time for the data collection. So will
Yes.
it help or is it not needed in real life?
So see, in this case, there is like, see, if multiple drones are there, you can collect the more data and you can cover more area in less time because ultimately you are sending a signal coming back. Okay. So if it is just small area, you can create, but the problem, what will happen here is you have to synchronize the GPS and time for all the drones. See,
Okay.
if your area is there of 1 square kilometer by 1 kilometer by 1 kilometer, or 5 kilometer by 5 kilometer, and if you are doing that survey using 100 drone, so the problem here it will create is in creating like synchronization. Basically, all the drone it can move together, but whatever the data they are capturing, that you have to stitch together afterward. So that
Okay.
will create an issue. Like generally, like when we create using just single drone also. Okay. That time also drone cannot collect like it's this like you heard in lecture that it is happening doing in zigzag scanning or parallel scanning. But like one image can store some sufficient data only, like in MBs or MGBs. So you cannot have just continuous image. You have to multiple image that you have to stitch together. So if it is from one image also, and that's why in photogrammetry sessions also we looked like how much overlap is necessary if you are considering the multiple photo. So you have to consider all those possibilities, and then after like it will reduce the time, but what I am assuming is that it will create issue in synchronization of various images and timing.
Yes,
Basically,
sir,
you
that I have to work on. That is my research work. But
yes.
if I am success in that, will it help or like it's kind of not needed like that?
See, I mean, I don't know. I mean, what applications you are. I mean, have you think about the applications like how it
Its
will help?
applications means now I am considering like a small construction site,
Hmm.
like a colony or something, small colony with uh, at least 12 or 15 buildings like that.
So see, if you think 12 or 15 buildings, okay, if just one drone is there, then also it can do the survey. Like, I mean, see, timing is like if you want to detect, it's like you are replacing the camera, security cameras using this, but it will become
Yes.
more costly. See, if
Yeah,
your application is just for street level or the street view, then I don't think so it will help. If it is for very larger area or something like that, then during very instantaneous event, flood, cyclones, landslides, in that case it will help. So like how I can relate to your application is, let's say you got some warning that uh, too much rainfall is going to happen in an area. Okay, like extreme rainfall, like some happening in Jammu, Punjab, and northern parts of India. Now, once you get to know, like through the meteorological warnings, if you are using single drone, it will take time to scan the surface and give the like how is it landslide going to happen or not. But if you have multiple drones, you can just reduce the time and you can collect the very easily. So
yes, sir.
that
Yes,
kind
sir.
of
Exactly.
application, it will help. But again, like synchronization will be necessary because you are collecting data with 100 drones. So all images should come together. It should process in one time. So those things will be a challenges. But yeah, in those application, it will help. Otherwise, for normal monitoring, I do not recommend it. I will just go with the camera, and then if needed, then just single drone, because single drone also, like we did a survey for one of the smart city which is coming. So for that also we just use one day. It took around like area was around 900 square kilometer. So it took around like 1 month data for data acquisition considering the very bad weather condition. But yeah, it can be done very easily. The thing
Okay,
is,
so that
another thing is,
disaster management, all only those things are
yes,
helpful.
the application part is very specific. So this is, have you defined or you are just still looking for the
No, actually, sir, this is my first year only. Still, my coursework is going on.
Okay, so here I will just give you some glimpse that here, I mean, if you have heard about the game development, so in that also people do use this LiDAR scanning and this scanning using this photogrammetry techniques. So what they do is they have to create a virtual environment in games. So for that they need a scanning of various small objects such as port is there, some let's say this vehicles are there, such as rickshaw is there, tempo is there. So they want to create those objects into their game. And rather than creating by 3D, like some Blender or some softwares, they are just scanning it and then they are putting it and then making it reference. So here is the application part is like if you look for those applications, then it might be very good. If you go for drones, first of all, it will be very difficult for you to get the drone license. You have to pay for that. Again, multiple drone system, so the requirement will be very specific. So better you can use some applications. Like there are like in our IT Gandhinagar campus, one student was working on this 3D reconstruction using different lights. So you just get me in touch with me, like you just send me a mail or something. I will share some of his papers. So he worked on this topic only, how depth perceptions we can achieve through this 3D scanning and how quick we can make those reconstructions. but for small objects, and how depth perceptions can be improved while scanning.
Can I get your personal mail?
Yeah, so I have shared in all the videos, shared in the last class. I'm sharing here again. So I have kept in chat, so you can contact me there. I will share some details there.
Okay, sir.
Okay, anything else, guys?
No, sir.
Okay, so if there is no more questions, next week we will talk about drones, types of drones, kind of processing which we need in drone, some drone data also we will see, and basically drones will see the next lecture. And then after subsequently on all the lectures we are having on digital image processing. So mostly you will work with the actual image processing work now onwards. So just one lecture of drone is remaining. Then after all the lectures are based on digital image processing. So you will get more of numericals in that. So currently those lectures are there. 3-4 lectures are very more on theory. But after this, after drone, there is a high lectures on digital image processing, image classification, machine learning part, how types of accuracy assessment, so IOU and other metrics you have heard of. So transformation, indices, and then there is a GIS part where you can use some software to do the analysis, which I showed you today, something like that. So next lectures are more on numerical part or the analysis part. So just drone is remaining. After that, there is a lot of things which we can do in numerically also, mathematically also, using coding also. So hope you guys join the subsequent sessions. Thank you for joining, and with that, we'll close today's session. Thank you for joining, everyone. Bye bye. Have a nice day.
Thank you, sir.
Thank you, sir.